So yesterday I posted a video about how I'm swapping out the modified sine inverter for the pure sine inverter that I just got and the reaction that my appliances had to that change. So that gave me an idea about doing a little video about showing visually the differences between a modified sine output from a modified sine inverter and a pure sine output, and we can actually see what that actually looks like. So the old inverter is an Ames 5000 watt inverter, modified sine output inverter, running from a 24 volt supply, and the new inverter is a 24 volt pure sine inverter, and I'm not sure how to pronounce the name. It's a Giante or something. I will put a link in the description, and we're going to see exactly what the difference is here. Now, the original purpose of the modified sine inverter was to power our hot water heater I'm using as an opportunity load here. So it was really its only job, and a heating element doesn't really care if it's a modified sine or pure sine. So I just bought the Ames 5000 watt modified sine inverter to take care of that. And it also originally was powering the bathroom circuit as well. So not much really in there using power, so not a big deal. Recently, it's now being used to power, or it was recently being used to power the refrigerator in the kitchen and the microwave as well. So those appliances don't really like the modified sine power, and I wanted to see exactly why. So I set up a little bit of an experiment to take a look at that, and we're going to check out what it looks like, what the difference is between the modified sine inverter's output and a pure sine. Okay, here's the setup. So here's the inverter on the bench. This is the Ames 5000 watt modified sine inverter. I am providing it its DC power from a bench supply here, 24 volts for the 24 volt DC supply, connected directly to its inputs here on the back. It's got some nice chunky inputs here, and you can see I'm measuring that on the meter here, on the bench meter for 24.1 volts. So we're getting a good voltage into the inverter. And we are measuring on the output side, connected to the AC output with our meter, and we are running 121 volts AC output. So everything's on and working. So the other thing we've got set up is our pure sine output. Now I've got that measurement connected to my variable supply, so I can turn the voltage down, and you can see that's very low voltage that we're working with on this side, but it's going to be the same waveform, and you can see it's about 4 volts AC coming out there, and we're measuring that with both my meter and the oscilloscope to show us what a pure sine output looks like. And that is the output right there. That's the live output right there. And you can see if I change the voltage level, it changes on the screen there, so we know we're looking at live data. Back to our 4 volts here. A little bit higher. All right, so that's pure sine output right there from the new inverter. Actually, this is from my other inverter that's actually even a better inverter. So that's a nice pure sine output right there. Now we're going to get to see why my microwave and my refrigerator didn't like the power coming out of this inverter, because its output looks like that. So that doesn't look the same to me. Yeah. So I think we can see why the microwave and the refrigerator weren't happy. And I also had problems with my dog's wireless fence as well, which is on this same circuit. So obviously that's not a good thing. So yeah, modified sine, pure sine. So it makes a difference